Heat recovery, we've kind of touched on this a little bit. Like yourselves again, there's people that would say to me still to this day, I don't know if that's doing anything. Now I'm talking about our systems, the system we've designed. I turn it around and say, turn it off. I don't argue, I don't get into the whole thing, it does work and all this. We turn around and say, I've done it multiple times, I says, should turn the system off to see if it makes any change. They don't have it off 24 hours till it's back on again. Because they see condensation starting to come in the windows. They see that the extraction's not working out of the bathrooms. So they turn it on, we'd always hear back, look, yeah, it does work, it is a benefit. Now, like everything breaks down from time to time. There's a particular house in Donegal and the person's not feared to say it. We've had a system installed now since 2016 or 17. The system broke down, the children got sick. We fixed the system, got it going. The system broke down twice, which is very rare. The children got sick. And he'll put it in writing to say the only time his children got sick in the house is whenever the heat recovery ventilation stopped working. But that's a proper design system and done correctly with the correct airflow rates and everything. People think it's just a matter of, if you look over here above Jonathan's head and then back here, people think it's just a matter of putting them on the ceiling and they put in cold air in their room. There's a lot more to it than that. A lot of people, so a house 2,500 square foot to 3,000 square foot, people think it's a waste of money, €8,000 to put in a heat recovery system. But you'll end up with clamminess, you'll end up with mould growing in the house, you'll end up with condensation in the house.
Can you put them vents on the walls, or does it have to go on the roof?
It has to go on the roof because you're taking up above that ceiling there, there's ductwork travelling everywhere to every single room. If you vault the ceiling, that's down to design and down to the architects again to make sure that they leave the vaulted ceiling with an extra 80 mil so you can travel the ductwork through that ceiling. So you can. And 80% of the houses now has these vaulted kitchens or a vaulted area that you have to work with. And it does be tricky. It does be tricky. Absolutely. 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 So you should always change the filters in this at a minimum every single year. Filters is the cheapest part of the system. For maintenance, you screw off these two screws, pull it out, put in the two filters. Virtually anybody can do it. We have the filters here, we can supply out. You would find that your house is more fresher. It's not stuffy. It does relieve of allergy problems. You will save a percentage on your heating system by a proper system running correctly. It'll kind of balance the house. It'll eliminate mould. If you have an airtight house, you have no drafts, you have no natural air coming into the house. So that's basically the purpose of the heat recovery, is to give you fresh air, fresh filtered air in your house to breathe. So it is.
Could they be switched off in the summer if you prefer to keep your windows open?
People say to me all the time, it says to all of us in this group, I can't open my windows. Excuse me if anybody says this in this room, but that's the most foolish term that anyone could ever say or do. You should open the windows and go about your lifestyle the way you normally do 365 days a year. The heat recovery kicks into play mostly in the winter time whenever the house is sealed and your windows and doors are closed, because then it's putting the fresh air into the house. If you open a door and a window, should you go and turn off heat recovery? My answer is no. It doesn't cost that much to run a good system, proper design system. Let it work away and do what it does. Just ignore it. Change your filters every year. Let it do what it does. Open and close your windows as normal.
What about kilowatt hours? What sort of usage would it be per day?
So the motor inside that unit there is about 300 watts or less. So it is depending on the size of system that you go with and that. Like, and money terms, because a lot of people in here will understand the money terms better, that unit there will cost about €150 a year to run. And you have two fans inside that unit. So it will.
And does it replace the need for the other types of electrical fans in bathrooms?
Absolutely. Absolutely. A lot of times we don't touch that because it's second nature to us. But yeah, absolutely. You've none of these flapping fans in the bathrooms. You don't need them no more. Absolutely not. So you don't.
Sorry, can you get them now with aircon as well, like done?
You can.
Or you better do a separate system?
Yeah. A lot of companies, we don't do neither of these, but a lot of companies is putting an electrical element in the ductwork, so it preheats the air going into the room. If the system's designed and done correctly, you don't need that. A lot of people are starting to add aircon into the systems and do all of that. That starts to become expensive. And to do that correctly, you need to put in a bigger duct to deliver the correct airflows to the rooms. There's a whole science behind airflows and everything like that. But you need to be putting in bigger ductwork and insulating all the ductwork internally in the house to stop condensation, because you're pushing cold air through that. So you're pushing cold air, I'm going to say at 5 degrees or 10 degrees, but the air around that could be 25 degrees, so you're going to have condensation problems. A small aircon unit now to cool a house is not that much. It's not that much. Again, benefits: improved air quality, energy efficient, reduces condensation, all the things that we've touched on. It's very hard to retrofit a system in a house. A bungalow, no bother. To retrofit a dormer bungalow, a story and a half, even a 2-story, it's difficult, do you know. That's really all on the heat recovery. Again, a full design system. So whose project is this? This is actually the job I was at this morning. So this job has been completely redesigned from this drawing here. So this here, again, there's no hot press in this house. I was on site this morning in this house. So we have our storage area upstairs where we can put our underfloor manifold. So there's no hot press anywhere downstairs in this house. This is the utility. I know the drawings, maybe some of you can't really see them correctly, but this is the utility. So the heat recovery unit was going in here behind two tall presses. So it was. I met the clients, they didn't like that idea. I was like, well, where do we go here? So there's a void here that we didn't see on the drawings. We couldn't visualize it, we couldn't see it in the drawings. So this is a full back attic the whole way back to here. So we looked round and we came to a compromise that now we have to redraw this whole drawing and put in here. And then start rerouting ductwork throughout the whole house, because there's no hot press design, there's no mechanical room designed. This is under the stairs here. Our hot water tanks going in under the stairs in utility. Again, the client's okay about it, but they weren't best pleased because they're taking up space where herself thought that she's going to have these nice flush cupboards with the stairs to hide the stairs, that you open the cupboards and you have storage. Now she's going to be looking at a hot water tank 6 foot tall, 600 circumference with a lot of pipework around it. It's a coincidence that's actually that job. So we're actually going to site in 2 weeks' time to start this job, but we have to redesign the whole thing. So we do. That's the block bolt house, concrete slabs. It's a brand new house, it's not a MICA rebuild. This is the size of the system of the unit. So it's over 1 metre long, it's 600 deep, and then there's pipework to come off this for condensation and that. This unit is built with insulation, it's not built with anything else. It's all sheet insulation that it's built with, to keep in line with keeping the heat that we're lifting out of the bathrooms and the en-suites, to try and keep that in and make the unit as efficient as possible. This is just a typical wiring schematic. So we give wiring schematics and meet the electricians on site. So the purpose of me on that particular job this morning, I met the contractor, the client, the electrician, and the groundsman actually, and we marked out everything in the house. We were there for about 1 hour and a half going through everything, but that's what we do at the start of the job to make sure everything runs smoothly. And
See, I was talking about the voltage ceilings. Could you run a track like say you put your pipe up underneath your ceiling
Mm-hmm.
and box around it with plasterboard and made a feature, you can do that.
Absolutely.
Aye.
So there's another particular job outside Letterkenny where the architect specified a ring beam around the house and put on the roof because the roof is so large and high pitch it was going to push the walls. So he put on a ring beam. So now we're running around on top of the ring beam with our ventilation and up slightly on the rafters end to come out in the room, and it's built in as a feature. So it is. It's actually the same architect as that house there. Any questions on any of that on the heating side of things?
Is that pure air circulation, or is there an option to actually bring the air temperature to a certain temperature to put it back into the room?
So inside the unit is cross flow filters, and it's whatever temperature we take from, we'll say, the ensuite or the bathroom. It's whatever temperature that filter can cope with crossing over, and then we're putting that warm air back into the room at maybe, if we're lifting at 21, we'd like to be putting it in at 19, 20 degrees. But it's purely only heat recovery, mechanical ventilation system. There's nothing in there to take the temperature up in the ductwork or nothing in our system. There is systems you have options to do that, but you're running like an electrical immersion in your hot water tank.
An immersion there.
Yeah, that's exactly what it's like. Yeah. That's, go ahead. Sorry.
For underfloor heating,
Mm-hmm.
what is the most efficient flooring option then on top of that? Or?
So natural stone tiles, stone effect, or so if we start at the start, polished concrete. So we've polished concrete down in what I'm going to say our old part down here, done 4 years ago. This was done last year. This is printed concrete, and then you've got your stone tiles, then just your standard porcelain tiles, and then laminated wooden floor, carpets, solid wooden floor. So tiles is the best, but most houses that we're doing, it's tiles and laminated floor and our semi-solids and that. Do you know, it all works fine with that. So it is. So we would have underfloor heating operating in houses and carpet that thick there, but you lay the underfloor heating slightly different and you adapt it to suit the needs of the client.
So we should make the decision
Well,
early enough.
you don't have to make a solid decision that it comes to time, I don't want that now, how's it going to affect my heating? As long as we have an incline of what you're doing, like tiles, wooden floors is all fine. If you're going for thick carpet, then we obviously would need to know, yeah. So.
Does the pipes need to be close from your garden to your house?
No, that's a good question. So the borehole can be up to, I'm going to say, 60, 70 metres away from the house, or as close to the house as we want. The flat loop pipes, the pipes in the garden, they can be the same. They can be up to 100 metres away. I've seen us times maybe 400 metres away, but we just had to increase the pump size to deliver the fluid back and forth, which is fine as well. So it is. If you have an area, so there's a house in Ballyliffin we done 2 years ago, and we put in an acre of a collector because it's a substantial house. There's 2 heat pumps in it, and that was what? About 200, it's more, it's about 400 metres from the house, and it came up a steep banking, but it's working 100% perfectly, so it is. But you just increase your pump size, your circulating pump, they circulate the fluid back and forth, so you do. So. Martin's going to take over now and run through the solar. Do you want to take a break for a second and maybe look at the heating stuff and come back in, or will we keep going?
Uh,
You free for time?
but should we keep going anyway?